Okay, let me try to solve this triangle. I'm going to solve it two different ways. First one I'm going to do is just the trig. I'm going to solve this using trig. So here's the process I would take if I was doing that. I would draw an arrow from the right angle to identify the hypotenuse. I would look at this triangle from the perspective of the given acute angle. So that makes this one the opposite, and that would make this side the adjacent. So from that perspective, this is how I would label my triangle. And then I would think to myself, so, ka, toa, and then I would think, which one am I using here? Well, I don't have anything on the H at all. I have the O and the A. And if I look at the ratios, oh, that's the tangent that has the O and the A. That's how I decide which trig function I would use. And it's the tangent of the angle from the perspective I set this whole thing up from. So it's the tangent of 28 is equal to O, which is X, over A, which is 14. I would close that out and make it a proportion. And then what I've been showing you guys is I like proportions because I can just multiply the bat and divide the ball. So there's your bat and your ball. So in this problem, it would be this times this. You can type it in exactly like this: 14 tangent 28, and you're good enough. That's all you need, and bam, you're done. So X is about 7.44. All right. So when I solve this with tangent, this side is about 7.44, whatever the units are. There's none given, so I don't have to give them back. All right. So that's the answer. I'm confident with that. I'm going to go solve the exact same problem, only this time I'm going to use the law of sines. I just think it's fascinating the way this plays out, so stay with me, please. I showed you guys how to do this little butterfly method of setting up your law of sines to make sure you have the right stuff with the right stuff. You need the angle and the included side opposite, and I have that on this one, but I don't have that on this one. But guess what? Easy to find that angle because this is 90 and that's 28, and 90 plus 28 is 118, and 180 minus 118, I believe that's 62. All right, so that's 62 degrees. Once I have that, then I could say the sine of 62 is to 14 as the sine of 28 is to X, right? And I could use the law of sines even though it is a right triangle. And let's see if this works out and gives us the same answer. That's what I'm curious about here. So how would I solve it? It's the proportions. So multiply the bat, divide the ball. I know it looks weird, but that's why I'm trying to show you how to do this. 14 sine 28, enter that, and then divide by sine of 62. Sine 62, enter. And looky there. It's the exact same answer. X is about 7.44. We found the same side, but we found it two completely different ways. We got the exact same answer. So the point here is if you set things up the right way, you've got more than one way to get there with right triangles. But and this law of sines you can use with non-right triangles. And so it's a bunch of cool ways to solve. Hope that helps.